I don't, is it the 14?
No, excuse me. It's m of x.
Yeah, that's what I meant.
Well, that's different than x. X is the amount of rainfall that fell. M of x is the number of mosquitoes that get produced based on that rainfall. Okay. Let me be the presenter again. Minus x squared plus 14x. So we have m of x, which is going to be the number of mosquitoes, equals minus x squared. What was the rest of it? Plus
14x.
14x. And x is in rainfall. Now, what kind of an equation are we looking at?
Quadratic.
Okay, good. What do quadratics look like? What kind of shape?
Big squiggles like parabolas.
Parabolas, exactly. Is the parabola that's going to open up or down?
I'm not sure.
All based on the sign that's in the coefficient of the x squared term. If that is negative, it opens down. If it's positive, it opens up. Okay?
Okay.
Now, their question is, what's the maximum amount of mosquitoes, right?
Mm-hmm.
Well, at what point on that graph, that parabola, are we talking the maximum amount of mosquitoes? That's the mosquito axis. That's x-axis.
14?
It's the vertex, is it not?
Yeah.
Okay. And it's this number, not this number. In other words, the hash mark on the x-axis is how much rainfall produces this number of mosquitoes. But what you always know about parabolas is that your maximum is the vertex, or if it's a parabola that looks like this, your minimum is the vertex. So we have to find out where the vertex is.
Okay.
How do we do that? We have a quadratic. All quadratics are parabolas that all have a vertex.
I don't think I know how to get to the vertex.
Okay, there's a rather easy way. There's a number of ways to find a vertex. A lot of it depends on what format they've given you the quadratic in. Well, this is in pretty standard format. So if I want to know the x coordinate of the vertex, it's minus b over 2a. So what would that be?
Negative 14 x
What's 2a? What's a?
x
No,
squared.
coefficient. Remember, these a, b's, and c's are never the x's. They're always their coefficients.
It's negative 1.
Okay. Times 2, negative 2. So the x coordinate of the vertex happens when x is equal to 7. But that's not what they asked. They didn't ask us, or maybe they did. I'm not looking at it anymore. But they want the number of mosquitoes, right?
We want how many centimeters of rain will produce the maximum number of mosquitoes.
Oh, well, we have our answer then. 7. In other words, what if there was a second part to that question, and they said, how many mosquitoes will it produce? What would you do?
Just do it the exact same way, but like.
No, this produces X coordinate only. Doesn't. Well, how would you? In other words, I want to know what this value is when X is 7. So I want to know M of 7. What do you do?
I don't know. Put it back the way it was.
No? Here's the thing. When you have something in the parentheses, when you're given a function, whether it's f of x or g of x or m of x, and they ask you to evaluate it at a particular x, you plug that number in for x. So it's minus 7 squared plus 14 times 7. Do the math. What's minus 7 squared?
49.
Negative or positive?
Isn't it plus minus?
No.
You don't really know.
No. This 2 right here only applies to the 7. Does not apply to that negative sign.
Negative 49.
Okay. Plus 98. That's how many mosquitoes you're going to get with 7 inches of rainfall. Or in thousands or millions. What is it, in millions? I doubt you'd get only 49 mosquitoes.
Okay, I have another word problem.
Okay. Probably do these without me looking at your page. So all I need is a function and read the word problem.
All right, so the function is p parentheses c equals minus 12c squared plus 120c.
Exactly the same kind of function. Except it's not in x, it's in c. So what is p of c and what is c?
What is what?
What does p of c represent? You always want to know that in these word problems. You want to know what c represents, and you want to know what p of c represents.
Doesn't it represent the function?
No, in the last case, we had m of x, where m of x represented the number of mosquitoes.
Oh, okay.
So read the word problem.
Hold on. The power generated by an electrical unit in watts is as a function of its current C in amperes is modeled by.
So P of C is the power. And C is, what was C again?
I think it's amperes.
All right. What's the question?
What is the maximum power generated by the circuit?
Okay. Now notice this a little different. In other words, last time we had parabola that looked like that, and they wanted this amount. Where does that vertex occur? In this case, they don't want that. They want, what is this value at this point on the c-axis? You with me?
I'm not sure how to go about that, though.
Same thing. We have a parabola that has a maximum right there at the vertex. So we have to find the vertex. Once we find the c value of the vertex, then we'll be able to plug it into the equation and get the amount of power that is produced. So the horizontal component of the vertex is, what was it again? What's the formula?
Negative 12c squared plus 120c.
No, the general formula for the vertex. Minus b over 2a. This is what you got to memorize. They'll always give you those. You got to know this. So what is that?
B is negative 120. So 2 times 12 is 24, so 24 is the denominator.
But it's negative. Because a is negative 20.
Got it.
Okay. So that's equal to 5. That means the horizontal component of that vertex is 5. We don't know what the y component is yet. How can we get the P of C value? We've got the C value. How do we get P of C?
I'm not sure. We're gonna have to do. We're gonna have to solve for it, right?
What did we do last time? The very last problem we did. It's exactly the same.
I can't remember.
You substitute the C value that we came up with in for C. In other words, we want to find out how much power is produced when C is 5.
Oh, okay. So I see. So at 5, we're trying to find the y value at 5.
Exactly.
Okay.
Only in this case, it's not really y, it's P of C. In other words, this isn't the y-axis, this is the P of C axis.
So we're just trying to find P of C.
Exactly. When C is equal to 5.
All right. So we just have to solve that out.
Yep. So 12 times 25, that's 400. So minus 400. No, it's not.
I can do it on my calculator if you need me to.
5. That's 3/4. So that's 300.
Okay.
What's the rest of it? Plus what?
Plus 300 plus, oh crap. 120 times 5 is 600.
Good. So the amount of power produced is going to be what?
300.
Okay. In whatever units they give.
So that's the amount of power generated.
In other words, the vertex is at 5, 300. In other words, the maximum value of that parabola occurs when C equals 5, and that maximum value is 300.
Okay.
One of the things you got to keep straight on these algebra problems is when we're talking about the horizontal axis and when we're talking about the vertical axis. In the first problem, the only number they wanted was this 7, or where it occurred on the horizontal. In this problem, the only number they want is this one. But in order to get that 300, you have to come up with 5 to plug it in.
Yeah. All right, my next problem is h of x equals negative 5x squared plus 20x plus 60.
60?
60.
60?
Yep, and the problem says an object is launched from a platform. Its height in meters, x seconds, after the launch is modeled by.
Okay. And what's the question?
What is the height of the object at the time of launch?
Well, what is x at the time of launch?
Zero.
Okay. What is h of x when x is 0?
So I have to solve that out.
Not really. Notice that when you plug in 0 for x, both first two terms disappear. In other words, it's always this number.
It's always 0.
It's not 0, it's 60.
Yeah, it's 60.
This
and then
equation tells you that it's being launched from 60 feet. Now, basically what we have is a rocket that's going to go up and then turn around and come back down. So what are they asking for? They ask for where it starts. That's that constant. In other words, it always starts when x is 0, right? So actually, I didn't really draw this picture properly. Let me draw it again in a different color. So it starts from right there. It goes straight up. And then at some point, it turns around and comes back down and hits the ground. Now, if you're looking at the rocket, that's what happened. But if you're modeling it with a quadratic, which that is, then it becomes easier to model it by drawing it as a parabola like that. Even though that is not the path of the rocket. The fact of the matter is that the peak is the same.
Okay, so the peak is, I'm still confused as to what exactly we haven't worked on the start time.
Well, the start time just means when x is 0. Look at the horizontal axis. 0 is always at the origin. That's 1 second. That's at 2 seconds. That's at 3 seconds, and so forth. Okay, so what's the next question they ask?
So 0 is 60.
Correct.
So the answer.
Well, what's the question?
The object of the time.
For the first one.
That's the only one.
That's the only question.
There's another question. There's a new question. Okay, the function is.
Oh, this is a different problem altogether?
Yes. The function is p of x equals negative 2x squared plus 40x minus 72.
Okay. We don't really need to know what p and x are. Because basically this is a math problem. That is a quadratic. Because all we're going to do is the same thing, regardless of what P means and regardless of what X means. What's their questions?
The fish population is in a certain part of the oceans of thousands of fish as a function of the water's temperature in degrees Celsius is modeled by. Which temperatures will result in no fish? Enter the lower temperature first. Lower temperature, higher temperature.
Okay. What is X?
I don't know. I'm not sure.
Read the problem again.
X is
Read it slowly and I'll stop you.
the fish population in a certain part of the ocean.
Stop. That's what that is. The fish population.
In thousands of fish.
Okay.
That's X.
No, that's not X. That's population.
Okay.
That's not the same as X. Keep reading.
As a function of the water's temperature.
Ah, that's X.
Okay.
X equal the water's temperature. When they say something is a function of something else, you know you have two different things. In other words, you don't just have the number of fish. You've got the number of fish is critical on the water's temperature. It goes up and down based on the temperature of the water. In what? Celsius or Fahrenheit?
Celsius.
Now what's the question?
Which temperatures will result in no fish?
Okay, so how am I going to figure that out?
Well,
what would P of X be with no fish?
which A, B, or C? Which one represents?
Hold on. We're talking about P of X. That's the number of fish that are in the ocean. We're not talking about what's on the right side. We're talking about P of X. P of X means the number of fish in thousands. So if they're talking about no fish, what is P of X?
0. So set the equation equal to 0.
If they're wanting to know what temperature produces 0 fish, they could have also said what temperature gives you 100,000 fish. So it all depends on what they say. Now, that's a quadratic that we can solve. Relatively easy. What's the first step on solving that quadratic?
By 2.
Good. Actually, let's take a negative 2 out. And there's a reason to take a negative 2 out. It's because you want your remaining quadratic to have a plus coefficient.
Yes.
Is that correct?
Yes.
And when you're doing math, whenever you do stuff like this, you should always immediately check. You don't want to wait till you finish the problem to check.
Yeah.
Because you won't know where you made your mistake. But if I check that right now and I redistribute that negative 2, I see that I get exactly what I started with. And that's what's important.
Yeah.
Okay. Now notice I can divide both sides by negative 2. Totally gets rid of that.
Yeah.
Okay. Now, I can solve this by factoring. How do I factor that? I mean, I think I can.
4.
What's the first step of factoring?
Factors of 36, 6 and 6.
That's the last step.
X and X.
What's the second step of factoring?
Plus minus on both of them.
It's not plus minus. You would not produce a plus 36 if it was plus minus. Remember that this number comes from those last two numbers being multiplied together. So the only thing we can say for sure at the moment is that both signs are the same. Now, that means they're either minus minus or plus plus. Which one are they here?
Plus plus, or minus minus.
Minus minus, because that comes from that sign. Term. Now, the third step, and this is why everybody has trouble with factoring, is they don't do it in 3 steps. They try to figure out the answer in their head in 1 step, which is not a good way to do it. Okay? First of all, let's talk about factors of 36, because that's what we need. What do we need? Factors of 36 to do what?
For what?
What do we need? In other words, to figure out what numbers go here and here. Step 3 is factors of 36.
Let's
add
see.
To the number 20.
I know the answer. It's 18 and 2.
And it doesn't matter where. But what we need was factors of 36 added to the number 20. That's the third step in factoring. Okay? So, what does that tell me X is? If x minus 18 times x minus 2 is equal to 0, solve for x.
Okay, sorry, what was that?
Solve that last equation. We factored it. Now we can solve it. We couldn't solve it as long as it was in a quadratic. But once we put it into 2 linear factors, it's easy to solve for.
Do I do negative 18x?
No. First of all, you don't want to multiply it back together again. That's going backwards. Well, you have to understand, and this is extremely important. This is Algebra 101 and maybe the most important thing of all algebra. If you have 2 things multiplied together that are equal 0, what does that mean?
One of them has to be 0.
Okay. So set both of them equal to 0 and tell me the 2 possibilities for x.
18 and 2.
Now, if I were to go up to our original equation and plug those in, I would get an answer of 0, regardless of which one I used. So the answer to the problem is 2 degrees Celsius or 18 degrees Celsius. Both of them produce 0 fish.
Okay. For the next one, for this next problem set, I would like to share screen.
Okay. Let me do that.
Because it's graphing parabolas. And it has a little graphing thingy on here.
Problem is I cannot write on your screen. Can you give me the equation and then we'll graph it on my screen and then you can figure out how to graph it on yours?
Okay. F of x equals negative 1/2 x minus 2 squared minus 4.
I'm sorry. What was it again?
F of x equals negative 1/2, and then in parentheses x minus 2 squared minus 4.
What format is that?
Vertex.
Good. Where's the vertex? It's the x coordinate of the vertex.
Is the vertex 4?
No. This number right here.
2.
In other words, here. Let's go over the standard format for vertex format. This is always where you should begin the problem. H and K are the vertex. H being the x-coordinate of the vertex, K being the y-coordinate. So what's the y-coordinate?
-4.
Okay. I want you to graph that. Do you have any other questions before this says graph it?
Well, we have to graph the whole parabola.
That's fine. We can do that. Where do you start? When you're graphing a parabola, what's the best point to start from? It's the most important point on a parabola.
Your vertex or your line of symmetry.
No, your vertex. You were right the first time. Where's my vertex?
-4.
2, -4. That is right. Let's see. If we call this 2, -4 would be maybe right there. Okay. So open up or down?
Down.
Good. That's somewhat what it looks like, but they want more than that. In other words, I could draw lots of vertex. I could draw lots of parabolas around that vertex. Maybe it looks like this. The only thing I know at the moment is where the vertex is. Okay? So let's put the vertex in there. Now, 3 points define a parabola. So you only need 3 points on here to draw this. That point is 2, -4. Put a dot on your graph there. What's the next best point to find? There aren't any x-intercepts. Doesn't ever cross the x-axis.
Next y-intercept.
Okay. So how are we going to figure out what that point right there is?
What form do we have to put it in?
We can leave it in this form. Question is what is the value of x when I'm on that point? When I'm on the y-intercept, what is the value of x?
-4.
Look at the x-axis. Go back all the way to the y-axis. What's the x value when I'm on the y-axis?
It's 0.
Always. Just like the y value is 0 when you're on the x-intercepts. Remember that. That's a huge fact to remember. So if I know the x value is 0, how do I find out the y value? Find out f of 0. I know the x value is 0. What's that come out to be?
What form are we putting it in?
We're not putting it in any form. We're just solving it. We're solving for f of x when x is equal to 0. Because that's the y-intercept. First of all, you need to know what to do when you see this. When you have a function that is a function of x, and somebody says evaluate that function, what is f of 2 or f of 3? In this case, what is f of 0? How do I solve that? What is f of 0? What am I going to do with that 0?
Divide it on both sides.
Plug it in for x. Whatever is in the parentheses, you plug in for x. If it was f of 1, I would plug in 1 for x. If it was f of 3, I would plug in 3 for x. But in this case, we want to know, where is f of 0? So we plug in 0 for x. What's that come to?
-8. -8.5.
No. What's -2 squared?
4.
So it's -1/2 times 4 minus 4. What's
Yeah.
-1/2 times 4?
2.
It's -2.
-2.
You see why? That negative sign didn't get squared. The only thing that was being squared was the -2. We did that to get that 4. And we still got to multiply it by -1/2, and then we still got to subtract 4. So we end up with -2 minus 4, which is -6. So this point right here is -6. Okay? Now, parabolas are symmetric about the line of symmetry, right? And the line of symmetry runs vertically right down through the x-axis. Or right down through the x-coordinate of the vertex. So my question is what is this value right there? In other words, we've got 3 points. You know how to graph that. You know how to graph that. We need this point right there. What is that? What's its x value?
6.
No. What's the x value of the line of symmetry?
2.
Okay. So how many units do I need to go to the right to get to this third point?
2.
That makes the x-coordinate 4.
Okay.
Y-coordinate's the same thing, -6. So this point over here is 0, comma -6. That's all you need to graph it. 3 points, find a parabola. So,
right, so
put dots on all 3 of those points, and then draw a parabola.
All right, so for the next one, the equation is y equals -1/2, and then in parentheses x minus 3, in parentheses x minus 7, and it's just to graph the parabola.
What kind of format is this?
Factored.
Which is which kind of format for a parabola? You have vertex format, you have standard format, and then there's one other, x-intercept format, which looks x minus p. They don't use h and k because we're not talking about the vertex. We're talking about where it crosses the x-axis. And that's P and K, P and Q.
Yeah.
So what is P and Q?
It's just y.
Okay, what you're doing, Nathan, is comparing this with this. So match up everything. What is A? Look at your standard format. Now look at the function they gave you, which is in that exact format. What's A?
It is -1/2.
What's P?
3. Negative, or just 3. It's -7, or just 7.
Just 7, not -7. You have to match it up with the format. The format is x minus p times x minus q. So here's our 2 points that we know this parabola goes through. So where's the x-coordinate of my vertex? Where's the line of symmetry? In other words, I know it looks something like this. Still only have 2 points, so I can't graph it without a third point. So let's find the vertex. We know that the line of symmetry always goes right through the x-coordinate of the vertex. What's the x-coordinate of the vertex? Going between 3 and 7, exactly halfway between.
4.
4 is halfway between 3 and 7.
I'm sorry.
Now, how do I figure out the y-coordinate of the vertex? I can't graph this parabola without that.
We set y equal to 0.
No. What did we just solve for? We just solved for the x-coordinate of the vertex. But in order to graph it, we need the y-coordinate also. In other words, I know all my points, right? This point is at 7, 0. This point over here is at 3, 0. And this point right there is at 5, something. If I have the something, then you got your 3 points and you can graph it.
Okay.
So how do I figure out this value right there?
How do you know it's 5-0?
I don't. That's not an O. I circled it to represent that's what you need.
Oh, okay.
How do you get it? Go back, look at your function. What is x?
X is 5.
Okay.
Or y.
So figure out what y is when x is 5. It's always the same thing. We've done exactly the same thing on all 4 problems.
Got it.
Come up with a number there.
5 minus 7 is -2. 5 minus 3 is 2. -2 is 1. 2?
Yeah. Which means that's 2 right there. And now I have my 3 points. In other words, just go to your graph, plot that point, plot that point, plot that point, and connect them with a parabola.
All right, we have one more problem with the parabola. Okay, the equation is y equals 1/5 x squared minus 2x minus 6.
Format is this then? It's not vertex, it's not x-intercept. There's only one other format.
Just try.
This is standard.
Yeah, standard quadratic.
You get a lot of quadratics in standard format. In other words, this is not in vertex format. It's not factored, so it's not in x-intercept format. It's in standard format.
Okay.
They want you to graph it?
Yes.
Okay. This is going to be a little harder when it's in standard format. There's a couple of ways to do it. We could complete the square and put it in vertex format, but that's pretty hard. So let's not do that. We could try to factor it and put it in x-intercept format, but that's kind of hard to do also. Whenever you have something in standard format, the x-coordinate of the vertex is rather simple. It's minus b over 2a. like the first part of the quadratic. So what's that equal?
2/2.
2/2. What number is that equal to? How do you divide by fraction? How do you divide by fraction?
I have no clue.
You flip and multiply.
Okay, so 2 times. So I would multiply 2 times 2 and 5.
You flip and multiply. So it becomes 2 times 5 over the 2. That is flipped.
Okay.
Okay? And then that becomes 5. So the x-coordinate of the vertex is 5. Let's find the y-coordinate of the vertex. We're going to need that. How do I find it?
We have to set it equal to 5.
Set what equal to 5?
X.
Okay. 1/5 times 5 squared minus 2 times 5. And I recommend doing it this way rather than trying to do any of this in your head.
Mm-hmm.
So 5 squared is 25. 1/5 of 25 is 5 minus 10 minus 6 minus 11. So our vertex is at 5 comma minus 11. Okay, that's the first thing we had to do. Again, we need 2 other points. Hold on. So what we have is a vertex way down here. Open up or down? What's the easiest other point to find?
The y-axis. Y-intercept.
And what is that?
Mm-hmm.
Standard format, it's always that number right there.
-6.
So 0 minus 6. Now we need to use symmetry to figure out what this point is.
Mm-hmm.
What's that point going to be? We know that this parabola is symmetrical about that vertical line.
I'm trying to graph it on my thing.
Probably better if you pay attention to my screen, and then once we come up with the 3 points, then just graph those 3 points on yours.
Okay. So we have the vertex, one side point, and then the other side point. Well, aren't you just able to eyeball that?
No, put a precise number on it. What's this distance between here and here?
That distance is -6.
No, it isn't. You're getting your x and your y-axis is mixed up there.
Oh, that distance right there is 5.
Okay, what's this distance right here?
Which distance?
From here to here. This thing is symmetrical about that line of symmetry. That's why it's called a line of symmetry. So whatever the distance was between there and there, it's the same from between there and there.
Yeah.
So what is the x-coordinate on this point right there?
The x is 7.
Okay, this is 5. That's 5.
Oh, it's 10.
Okay. And what's the y-coordinate?
The y-coordinate is -6.
Yeah, it doesn't change. In other words, when you're dealing with an up and down parabola, and you're looking for that point on the other side of the parabola, the symmetrical point, the y-coordinate never changes. You just have to figure out the distance between here and here, double it, and you get that distance there. Or you get the whole distance. And in this case, that's 10. There's our 3 points. So on your graph, label that point, put the numbers in. Well, you might not need to put the numbers in, but make sure you find the right point. Same thing with that point, same thing with that point. Now you have 3 points, draw a parabola through it. What else you got?
I have another lesson. Okay. I got what are the zeros of the function and what is the vertex of the parabola?
Okay.
The equation is r squared minus 6r minus 55.
Okay. Parabola open up or down?
I don't know because what do you base? It opens down?
No. You do know because it's if the coefficient of the squared term is positive, it opens up, always. If the coefficient of the squared term is negative, it opens down. Well, the coefficient is a +1, so it opens up. Now, you almost always need the vertex. So let's figure out what the vertex is. Easiest way is to figure out the x-coordinate of the vertex. What's the equation? What's the general formula for that?
A over 2a.
In this case, what does that correspond to?
6 over 2.
So the x-coordinate of the vertex is 3.
Yes.
The y-coordinate of the vertex.
Well, if we set the x is equal to 3 in the 18.
Where are you getting 18? We got 3 squared minus 6 times 3 minus 55. That's 9 minus 18 minus 55. That's equal to minus 64.
Okay.
So if we go over here and draw it, we're looking at something like that. 3 comma minus 64 for vertex. But on this one, they don't want the y-intercept, they want the x-intercepts. Correct?
Correct.
So what am I going to set equal to 0 if we're looking for the x-intercepts?
The function?
Let me ask it again. What is y equal to when you're on the x-axis? In other words, I've got 2 intercepts, somewhere like there and there. What's the y value of both of those?
0.
Okay, so we set y equal to 0 this time. We don't plug in anything. What we do is we solve this equation, and that will give us our 2 x-intercepts. How do we solve that? First, you always try factoring, because that Usually is the way you solve it. Factor this. First step.
10 or 15 times.
First step. Not third step. First step.
Oh, X's?
Well, in this case, R's.
Yeah.
Second step.
They're going to be both negatives.
No, you would not get a negative 55 if they were both negative. It would be impossible. Negative times negative is a positive.
Correct.
Remember, this number comes from the L of FOIL.
Yeah.
So the signs have to be opposite. One has to be positive, one has to be negative.
Correct.
That's the only way you could produce a negative constant.
Mm-hmm.
If they were both negative, you'd have a positive constant. If they were both positive, you'd have a positive constant. So when you're factoring quadratics, the most important thing to look at immediately is that. Because that tells you how to figure out what both signs are.
Mm-hmm.
Now, what's the third step? Verbalize it.
Well, factors of 55, 11, and 5.
That do what?
That add together to create 6, negative 6.
Actually, the best way to look at it is factors of 55 that subtract to the number 6. Subtract because that's a negative sign. If that's a positive sign, then they would have to add to the number 6. So you're right. We need two factors that subtract the 6. Well, there's our factors. Now I got to figure out where the 11 goes and where the 5 goes.
Well, it's got to be negative 11 and 5.
Correct. So, what are the points on that one right there?
Um, 5.
0 is the x.
0, 5.
Hold on, I made a mistake. 0 is not the x-coordinate. The x-coordinate is minus 5.
Minus 5, 0.
0, exactly. And over here?
Minus 11.
It's not minus 11.
11, 0.
Remember, it's always the opposite of these factors. In other words, if I'm looking at an r plus 5, well, then the answer is negative 5. If I'm looking at r minus 11, then the answer is positive 11.
Yeah.
Got my 3 points. Once you got 3 points, you can draw your parabola through those 3 points.
All right.
So those were like 4 problems that all had to do them all a little different way. In other words, they didn't want us to just graph this. They actually wanted to know where the x-intercepts were also.
Yeah, correct.
Whereas if they just wanted us to graph it, I'd figure out that point first. Then I'd be able to figure out that point, and I would have my 3 points. I wouldn't need the x-intercepts.
Correct.
When they specifically ask for the x-intercepts, the thing you got to always remember is that x-intercepts, y is 0. Y-intercept, x is 0.
Yeah.
Those two go together. I don't know why. Students have a hard time remembering both of them. But they're pretty straightforward.
Mm-hmm.
All right. Nathan, I will let you go.
All right. Thank you.
Talk to you next time.
All right.
Bye-bye.
Bye-bye.